Hello everyone, my name is Seyfun, and in this lecture we will capture a volatile memory with FTK Imager. So capturing volatile memory is a crucial part of digital forensic investigations because the random access memory stores temporary data that disappears when a computer is powered off. This data may include active processes, encryption keys, malware, open network connections, and user activity traces that are often lost once the system shuts down. FTK Imager, developed by Access Data, is widely used for disk imaging, but also includes a useful RAM capturing feature. Now in this lecture, you will see a step-by-step guide on how to capture a RAM with FTK Imager. But to start the volatile memory capture as an incident response officer, you should ensure three conditions here. The first is system state. The computer should remain powered on and unlocked. This keeps volatile data in RAM intact and accessible. Avoid rebooting or logging out, as these actions clear memory contents and may remove crucial evidence. Since FTK Imager typically runs from an external device, plug in USB drive containing the FTK Imager executable or other trusted forensic tools. Remember, if you write Kane OS ISO file in USB, the FTK Imager, you can actually use the FTK Imager from that ISO here. Just plug in the Windows machine and you will see that in the Windows Tools folder. And also avoid installing new software directly on the system being investigated to minimize data alteration. Running from an external drive helps preserve the original state of the evidence. And also secure the evidence, safely eject the USB and document the hash files, file location, and any additional case notes for a clear chain of custody. Now, the image is ready for analysis with the tools like volatility, where artifacts such as active processes, network connections, and user actions can be thoroughly examined. Now, also, let's get started with capturing RAM using FTK Imager. I have installed FTK Imager in the system. As you remember in our previous lecture, we will open it, click on yes, and ensure that you have administrative privileges on the machine. This level of access is necessary to view and capture the contents of memory and use the correct version of FTK Imager. It has the 32-bit or 64-bit to match the system's architecture. In this case, I have the 64-bit operating system with 64-bit based processor, and I also have the FTK Imager 64-bit here. So running the appropriate version reduces the risk of compatibility issues during the capture process. And also start the FTK Imager on a machine where you intend to capture random access memory. The main interface provides access to various options for imaging and forensic tasks, including random access memory capture. Now, in the toolbar here, you can see, click on File and select Capture Memory from the drop-down menu. So this option is specifically designed for capturing machines' volatile memory. And also, FTK Imager will prompt you to choose a folder for saving the memory image file. Ideally, select a location on a separate drive or partition to avoid overwriting critical data on the system's primary drive. In this case, I will just save it in desktop. And also, you need to name the, if you don't want the default name, of course, case 001 test here. Oops. Case 001 test here. Now, also provide a descriptive file name. For example, it will be more good to first provide the machine name, random access memory, and year, month, and date to easily identify and organize the image later, including details like the machine's name and capture. And you can see the device name. You can get the device name from about here. And also, in this case, we don't have any hashing, but we will include a page file. And after configuring these settings, click on the start. Also we need to select the desktop. Yeah, after configuring these settings, click capture memory to begin. The process may take a few seconds to minutes depending on the system's random access memory size. Avoid interacting with the system during the capture to prevent new data from overwriting valuable information in memory. Now, when the acquisition completes, here the FTK Imager will display the calculated hash values for the image. Oh no, in this case it didn't display because for the capture memory, if it will be the disk image, it will show the hash values, but in this case it didn't. Now that's it. Here, as you can see here, we have the page file in size of 1.87 gigabytes and the memory, which is 9 gigabytes. Now, once the RAM is complete, you will have the mem file saved in the specified location. This file represents an exact snapshot of the system's random access memory, which can be analyzed for artifacts using dedicated memory analysis tools like volatility or recall. So FTK Imager does not offer RAM analysis features, but its compatibility with other tools make it ideal for quick, reliable memory acquisition. So using FTK Imager to capture random access memory is a straightforward process that requires minimal setup and knowledge of forensic principles. After capturing, the memory image can be truthfully analyzed using specialized tools, revealing potential evidence that may be crucial to an investigation.